Hello and welcome. Today we're looking at stereochemistry, and the question here says circle the chiral molecules. So we're looking at molecules A, B, C, and D. If we look at molecule A, we see that it has a one possible chiral center right there, and we need to determine whether that's really a chiral center. A chiral center or asymmetric carbon has 4 different groups attached to that carbon. So if we look at this carbon here, you'll see that it has an OH group here, so that's group number 1. It has a CH3 group, number 2. It has a chlorine, group number 3. And then it has an ethyl group, number 4. So because there are 4 different groups, this A here is a chiral center. Number B. Again, we look at this center here, and we see that it has chlorine, number 1, bromine, number 2, CH3 number 3, and an ethyl group number 4, and because it has 4 different groups, that's also a chiral center. Number C, we see that it has an OH here, that's number 1, and because it's coming out, that means there is a hydrogen that's going in, that's number 2, and then we have an ethyl group and ethyl group then. Because those 2 groups are similar, that means you don't have 4 different groups around the center, and therefore that is not a chiral center. The last one, number D, we see that we have bromine there, that's group number 1 coming out, but we also have a hydrogen that will be number 2 going in, and then we have an ethyl group, that's number 3, and we have a methyl group, number 4, and because you have 4 different groups, that's also a chiral center. So we see that A, B, and D are chiral molecules because they have one chiral center. And that also means that you don't have a plane of symmetry.